Dear students, in this video lecture we are going to study the concept of pressure and the pressure exerted by liquid column. For that, first of all we will see what do you mean by the pressure. Pressure is the force per unit area. The force is the force which acts normal to the surface area. The force which acts normal to the surface area is called as thrust. Therefore, the pressure is the force which acts normal to the surface area per unit surface area is called as pressure. Now, the perpendicular force to the area is called as thrust. Therefore, the pressure is also called as thrust per unit area. SI unit of pressure is Newton per meter square. The dimensions of pressure are M1, L-1, T-2. Pressure is a scalar quantity because in pressure the force is always perpendicular to the surface area. From this what you will see that the pressure is inversely proportional to area for given amount of force. Therefore, with decrease in area, there is increase in pressure. As area decreases, the pressure increases and vice versa. For that, we will consider a simple example. I had got a pen. The cap of the pen is removed. One side is pointed, it's the tip, and other side is the flat circular part of the pen, bottom. If the pen is taken on between two fingers, forefinger and the thumb, and if I apply a equal pressure on both sides of the pen, what you will see that the pressure on the forefinger is more because its surface area is too small as compared to the surface area of the bottom. Therefore, pressure exerted by the tip is more and the pressure exerted by the end of the pen, which is circular, is small. Pressure plays very important role. The substances which can flow are called as the fluids. Liquids and gases are the fluids. Liquids and gases are the fluids. The important property of a fluid is that it can flow. Fluids do not have their own shape and size. They acquire the shape of container. Fluid opposes the deformation and the fluid exerts pressure on the walls of the container. This is a bottle full of water. If I pierce a hole on any side of the wall of this bottle, the water will come out because the pressure is exerted by the water on wall of the container. At the same time, this liquid inside the bottle also exert pressure on the bottom of the container, we will find out how much is the pressure exerted by the liquid column. For that, we will consider a container with a water. Consider it's a container filled with water or any liquid. We are studying the properties of the fluid, but mainly we are thinking of the properties of the liquids. Let us consider an imaginary cylindrical liquid column. It has a height h. Rather, you can say that the depth of imaginary liquid column from the surface of the liquid is h. This liquid column exerts pressure on the bottom of the container. We will find out how much is the pressure exerted by the liquid column. For that, we will write what pressure is equal to force perpendicular upon area, the force which acts perpendicular to the surface. Here, the force exerted is the weight of the liquid column divided by area. Weight of the liquid column is m into g, where capital M is the mass of the liquid column, g is the acceleration due to gravity. Therefore, gravitational force, that we call it as a weight. Weight of the liquid column mg, and the surface area of a cylinder, cross-sectional surface area of the cylinder is capital A. Then the pressure exerted is equal to what mass is? Density into volume into acceleration due to gravity divided by A. Volume of liquid inside the cylinder is area of cross section into height into acceleration due to gravity. A get cancelled. Therefore, pressure exerted by liquid column P is equal to, I will write it as rho into H into G. This proves that the pressure exerted by liquid column P is directly proportional to depth of the liquid column that is measured from the surface of the liquid. The pressure exerted by the liquid column is directly proportional to density of the liquid, and it does not depend on the area on which the liquid is exerting pressure. This will give how much is the pressure exerted by the liquid column. Now, if it is the pressure exerted by the liquid column, then what about the pressure exerted by the air in the atmosphere? The pressure exerted by the atmosphere is called as the atmospheric pressure. In atmosphere, air is the major constituent. The pressure exerted by the atmosphere on the surface is the atmospheric